The question posed by Ian and many others is, what will happen if we drain Earth's oceans and pour the water onto the Curiosity rover? How will Mars change as it accumulates this water? What if we open a portal at the bottom of the Mariana Trench and let the oceans spill onto Mars for fun? The Curiosity rover is actively searching for evidence of liquid water, and I thought we could make its task easier. There is indeed a lot of water on Mars, but mostly it is frozen. Liquid water cannot exist for long on Mars due to low temperatures and lack of atmosphere. Before we submerged Curiosity, its temperature sensors recorded air and surface readings fluctuating from -100 to 0 degrees Celsius, with rare moments when the surface temperature rose slightly above zero. On this phase diagram of water, the line represents the average atmospheric pressure on Mars, which, by the way, almost perfectly intersects the triple point of water. In theory, liquid water can exist on Mars at the lowest heights on warm days, as atmospheric pressure is higher at lower elevations. However, on most of Mars's surface, water either remains frozen or sublimates, transitioning from ice to vapor. But the oceans we pour onto Mars won't freeze immediately. We pour a lot of water quickly, and the temperature on Mars isn't that critical. Average temperatures at the North Pole range from -30 to 0 degrees Celsius, and only the upper layer of water freezes because ice retains heat well. Additionally, the oceans are salty, and salt slightly hinders the freezing process. Currently, the Curiosity rover is in Gale Crater, a round depression on the surface of Mars with a peak called Mount Sharp in the center. We are pouring a lot of water, which will start turning Gale Crater into a lake, similar to what happens on Earth. As the flow continues, the lake fills up, burying Curiosity under hundreds of meters of water. Surprisingly, the water will freeze simultaneously from the top and bottom, as the surface of Mars is also below zero. Stones and soil will likely merge into frozen chunks of ice that will float to the surface like icebergs. Eventually, Mount Sharp will become an island surrounded by water beneath an icy crust. However, before the peak disappears completely, water will overflow the northern part of the crater and begin to flow over the sand. The water will cascade down northward, accumulating in the northern polar depression, forming a layer of sea ice and stones on top. When such a flow of water occurs on Mars in real life, the trickle of water quickly freezes and sublimates, not having time to go far. However, we have a lot of ocean. Gradually, water will fill the northern polar depression, covering the inactive landing modules, Phoenix and Viking, unless they are frozen in ice, and float to the surface. If we look at the rest of Mars, we will see that there is still much land far from the water. I am a big fan of maps, having spent many years drawing and studying them, and I must say this map looks quite dull. It's just a large empty area with a small ocean at the top. Fortunately for us, and not for Mars, we have not yet exhausted the ocean. At this stage, water fills Valles Marineris, creating unusual shorelines. Here, water and ice now reach other rovers, carrying them south. Ultimately, the stream breaks into the crater covering the lowest point on Mars, and Perseverance will likely be destroyed by an icy waterfall. In my opinion, the rest of the map starts to look quite good. Look at this curved coastline. It's really a nice map, one that if it were on the cover of a fantasy novel, I would spend a lot of time trying to figure out where my kingdom would be. The area of land in the southern hemisphere is divided into several large islands and countless smaller ones, and it also looks very attractive. A great map. Water quickly covers most of the high southern plateaus, leaving only a few islands, and then finally, the flow stops. The oceans on Earth are depleted, and the rovers have been damaged by water and are likely out of order. Olympus Mons and several other volcanoes are still above water and not yet covered. Olympus Mons still rises more than 10 kilometers above the new sea level. Oceans on Mars will last a very long time. The surface of Mars already contains at least 2% ice by weight, and this ice is gradually transported to the poles through sublimation and atmospheric circulation. But this process is incredibly slow. We cover the planet with a vast amount of water, and the ice will become thicker and thicker as the water beneath it cools. Ultimately, the oceans will freeze completely, and the surface will very slowly sublimate towards the poles. And if the ice collects enough dirt and stones, they will open up and accumulate on top, like dirt on melting snow, until perhaps the equatorial regions of Mars turn into a dusty, rocky landscape based on ice. However, perhaps none of this will happen. Water is a powerful greenhouse gas, and with so much new water available for evaporation into the atmosphere, Mars might warm up, and the oceans could remain liquid, as they do on Earth. There is only one way to find out,